We're going to be going over adding and subtracting polynomials in this video, and because we're going to be using some new vocab, I've got some new words for us to go over. So we've got a monomial, so that's this here. This is term. We're being talking about terms, so remember terms are parts of an expression that are added together. So this is the term of the form a times x to the m, where a is a constant and m is a positive whole number. So a monomial could be like 3x to the fourth. It also doesn't have to just have one variable. You can also have like 9x to the third, y to the fifth. That's also a monomial. You could also have just the number, just 10 or 7. Those are monomials because you can write those in this form, ax to the m, in that form, just by doing 7x to the 0. And if you remember, x to the 0 is just 1, so that's just equal to 7. So all of those are examples of monomials. And for a polynomial is just a monomial, so this is a polynomial, or it's two or more monomials combined by addition or subtraction. Okay? All right. Let's see. Binomial. So this is just a polynomial with exactly two terms. So that could be like 3x squared plus 2x. So that's a binomial. And then a trinomial is a polynomial with exactly three terms. So that's like 2x squared plus 5x minus 10. That's a trinomial. Alrighty, let's move on. So we have to talk about the degrees of polynomials. So first of all, the degree of a term, so that's the sum of the exponents of its variables. So, let's see, let's do 5x squared. So the degree of this term is going to be 2, all right? If I wrote another one, let's do 7x squared y to the third. The degree of this term is going to be 5. So on this one, we just have one exponent, and that's 2. On this one, we've got two exponents. We have 2 and 3, so we add those up and we get 5. The degree of a constant, as I went over in the first slide, the degree of a constant is 0. So that's, if we looked at, say, 11, so that's like 11x to the 0. So the degree of that would be that 0 right there. All right, I've added a few polynomials down here. So we're going to find the degree of a polynomial. So the degree of a polynomial is the highest degree of all its terms. So if we go ahead and write down the degree for each of these terms, this 3x squared has a degree of 2, this has a degree of 1, and this has a degree of 0. So the degree of this polynomial is 2. Okay, let's move on to this one here. So the degree of this one, this term is 5. This one is 2 plus 9, that's 11. And this one is 1 plus 2, which is 3. So the degree of this polynomial is 11, the highest degree of all of its terms. All right, so let's do some examples of actually combining or simplifying these monomials, which they're in the directions they're going to say add and subtract monomials. Really, it's just simplifying the expression, which is to combine your like terms. So if you want to go through and identify your like terms, you can do that by underlining. Sometimes that helps. Like I could say, well, this one is a like term with that one, so I want to get those next to each other. So my next step is to write it as an addition statement, because if I have addition, then I can use the commutative property of addition and move things around as needed so that I can then add them up. So I'm going to put the 14x and the negative 12x next to each other in this expression. And now I can just add this and this up. So 14x plus negative 12x, that's just 2x. So I get 2x plus, and then negative 3y. I can either leave it like this, or I can write it as 2x minus 3y. Either way is okay. All right, let's move on to the next one. So again, what we have here, we've got 5u squared plus 4v squared minus 6u squared minus 7v squared. So let's write it as an addition statement so we can then move our terms around as needed. So this becomes this expression. All right, so I'm going to move this guy over here, and we'll just flip-flop these so that the u squareds will be next to each other and the v squareds will be next to each other. So I get this like that, and then I'll combine my like terms as I've already got them next to each other. So I'll get 5u squared plus negative 6u, that's just negative 1u squared, or just negative u squared. Then plus 4v squared plus negative 7v squared is negative 3v squared. So I can write this as negative u squared minus 3v squared, or I can leave it the way I have it. Either would be okay. I'll just write it as a subtraction statement. All right, we're going to add and subtract polynomials now. So this is called adding and subtracting polynomials because I've actually got these parentheses. So I'm adding this polynomial to this polynomial. And because it's addition, I really don't need the parentheses there. I can rewrite it as 4y squared plus 10y plus 3 plus 8y squared minus 6y plus 5, just like that. And if I want to, like I said, I can underline these things and identify which ones are the same or are like terms, or if you have a highlighter, you can do that. So I'll just use underlining. So I'll underline those guys are like terms, these are like terms, and these are like terms. So I got to get those next to each other. So first step is to write it as an addition statement. So I'll get 4y squared plus 10y plus 3 plus 8y squared plus negative 6y plus 5. Now I can move things around as I wish. 4y squared plus negative 6, So it's going to be 4y squared plus 8y squared plus 10y plus negative 6y plus 3 plus 5. Okay, I think we've got everything covered there, and all of our like terms are next to each other. So now we can just add the coefficients of each like term. So this will be 12y squared plus, and then 10 plus negative 6 is 4y, and then plus 8. So that's the simplified version of this addition statement up here, where we're adding these two polynomials together. All right, so this will be our last one. We're subtracting polynomials on this one, and this is the toughest part of all of this, when you're subtracting polynomials, because I'm subtracting all of this here, this entire expression from the first one here. And so we have to be real careful when we do this. I like to write this as just quickly as an addition statement like this, just where I'm just adding the two polynomials. I haven't changed what's inside the parentheses yet. And now when I look at this, I have plus and then negative 1, and so it helps me to remember that I need to distribute this negative 1 to here, here, and here. So let's do that right now. So we'll have, make this black pen. So we've got 3b squared minus 4b plus 1, and then plus, so negative 1 times 5b squared, that's going to be negative 5b squared, and then negative 1, or I should say this is minus, and then negative 1 times b is negative b, and then minus, and then negative 1 times 2 is negative 2. Okay, so let's go through and kind of simplify what we have here. All right, so we'll go through and simplify everything. Again, this is now just addition here. I'm just adding these two expressions. So I can actually drop my parentheses. Oh, and I should make this plus negative 4b, and then plus negative 5b squared. This is just, if you're subtracting negative b, that's just plus b. And then subtracting negative 2, that's just plus 2. So now, let's get all of our like terms together. So this and this are like terms. This one and this one, and then this one and that one. So we'll put all these next to each other using our commutative property. So 3b squared plus negative 5b squared plus negative 4b plus b plus 1 plus 2. All right, so now we just need to add our coefficients. So this is going to be negative 2b squared plus negative 3b plus 3. And there is the simplified version of this expression up here.